Alright, so I wanted to go ahead and summarize how this video went. Here you have a picture of me on the right, and on the left you have a computer, and the computer is slapping me, or I'm slapping the computer, either way. Not much was accomplished in this video, but it happened. This video was recorded, and if you're expecting any revelations, this is not the video for you. This is me poking around for half an hour, unable to figure out what I'm doing in WebGL, but you can't win them all. So here it is. Enjoy it, and don't expect much. Whoa, hold the phone, folks. Hold the absolute phone. Please hold it, because I just went and read this QMath article, and I'm going to give you the answer right now before we even start the video. It gets done, right? We do this, right? So we read this article. Here are my notes. Transformation matrices. We've got 4 types: rotation, reflection, translation, and resizing. You use matrix multiplication to perform this. One type, it says right here, rotation. So we're going to do 2D rotation. Then we need a 2x2 rotation matrix, n-dimensional space, n by n, right? Or they're orthogonal, they're determined as 1. I don't know what that means or why it's important. But if we're going to rotate counterclockwise by some angle theta, which is what we want, the standard form for a rotation matrix, it gives it to us here. It is cosine of theta, negative sine of theta, cosine of theta, right? So we're going to do all this math. Here's the standard form. It says to take that standard form, multiply it by your point, which is essentially what we were trying to do in our code here. So I updated our code to match that. Basically, they say if you do this and you multiply it out, you get this. This did not match what we had, but it was close, so I updated it to be exactly this. And then look at this. Whew, we got a rotating square. My faith in OpenGL has been restored. And that's it. Now you can watch me struggle to get this done for half an hour. Welcome back for another episode of OpenGL Cube, WebGL, and all things like that. I have some Obsidian notes. I was Googling around looking at things about OpenGL and WebGL. And today, I think I have 2 goals. Number 1, rotate our square. Number 2, add some color. And, make the fragment shader a little bit better. And I think I want to do these 2 things before we get to the cube part, because we could draw a cube and it would just look like a white blob, kind of like our square does, until we add some color and we can tell the differences between the vertices and all that, and we can rotate it dynamically, do a little animation. I don't know if there's any point in trying to go 3D. Let's start with 2D and work our way there. So let's see what we could do. Where do we leave off with this? Get the server back up. Get the guest session up. Go to localhost 8000. And here we are. We're back. For some reason we have this long cube again. Did I mess it up? Oh, we have the aspect, which we're back again. Okay, let's get rid of that for now. Okay, we're back. We got a square. Okay, now how could we change our fragment shader a little bit? I actually have no idea. All right, so let's start with the rotation part. Rotate vertices, OpenGL. Maybe I should look for a WebGL. WebGL 2D rotation. This stuff just gets so far beyond me so fast that I can't even follow it. All right, so it's passing uniform matrices. Maybe to start, we could just say, let's get some animation and say x is 0. And for all these, we'll say x minus x plus, x minus x plus, x minus x plus, x plus, x plus, x minus. What happens if we throw x's in here? And then we change the x and do it again. And then one of the sites I saw had something along the lines of request animation frame or something. Yeah. So we had like a redraw function, all this stuff. And then we could say x plus equals 10, window.request animation frame, redraw, and then we can call redraw once, should start looping. Let's see if that actually happens. Whoa, did we get an error? No, did we forget to clear? Where did we do that? Anyway, yeah, here we go. Geo clear. Let's do that at the beginning of our redraw. See if that helps. Okay. But we're also setting x to 0, so we shouldn't do that every time. Whoa, it's gone. Okay. Can we set timeout? Or should we set an interval? I don't know what this animation frame thing's even doing. Yeah, let's set an interval. We're going to call redraw every 1,000. See if that... Whoa, okay. Maybe 10 is a lot. Where are we plus equaling 10? Whose idea was that? Let's try 0.1. We'll call redraw once. Okay, wow, we have animation. That's great. Let's set timeout for now. We don't want it flying off. It only gets called once. Okay, so that's cool. So we can animate. Now, how do we rotate? That is the question. Angle is 0. Now I guess we could take our vertices and we could somehow WebGL rotate array of vertices. There's got to be, I know there's like a library that does it, I thought. Surely we don't have to do sine and cosine ourselves or do it in the shader. Let's see. Matte rotation. Where is that coming from? WebGL matrix library, GL matrix. Okay. GL matrix. Do we have access to this or do we have to include it somehow? Yeah, it's not included. Geomatrix CDN. Maybe there's something out there that we could just grab. Okay. I'll take it. Where's the link? I don't see a link. Hello. How do you use this CDN site? Is it not there? Okay, I give up. There we go. I'll take the minified. And we'll stick it up here right above our other script. Oop. Probably don't even need the type. Okay. Now how do we use it? GitHub. Okay, maybe it's just geomatrix. Well, do I have it now? Oh, I do have it now. Okay, geomatrix exists. That's great. How does this work? mat4.create. This could be tough. Maybe a 2D matrix? 2 by 2, 2D. 6 elements, okay. Well, that's kind of like what we have. I think. Maybe just in the other direction. A, B, C, D, T, X, T, Y. Huh. Rotate. Okay. Can we turn this into a 2D matrix first of all? Is there a create? There is. Identity matrix 2. How do I set it to values? I'm lost. Show me some examples, please. I'm terrible. Let's try this. Huh, why is this so hard? This is, this is almost beyond me. Okay, I really nearly don't understand this at all. Can I do it in the shader? Can I pass something else into the vertex shader? Attribute. No, it would be a uniform. Float. Angle. How do you rotate a vec2? Interesting. Okay. I guess I'll just copy this verbatim. Why not? Oh, man. Really in over my head here. And then a vertex position 0, 1. So that's a vec2. We can just say new x, new y, 0, 1. See if that works. See what happens. Probably get an error. No, no error. Okay, that's great. Now, how did I set that variable going in? Uniform. We bound some data. Use program. uColor. Ooh, okay, so we have to get the variable. So let's say program dot angle equals gl dot get uniform location program angle. Uniform yeah, how do we do this? Uniform 4V. What are my alternatives? Uniform 1F. Ooh, that's what I need. Uniform one-dimensional float. Okay, and the angle will be, oh, we got to pass program.angle and then the number. We'll say 0.5 for now. See what happens with that. Whoa, it's weird. Interesting. That's pretty cool, actually. Now, what if we rotate that? What if we do math.pi? Aha! Ooh, this is good. Times 3/2. Huh. Okay, this is awesome. Now let's just keep that thing rolling. Angle. And then we could say x plus equals angle plus equals 1 degree, or radian. I guess that's probably too much. Set interval Whoa, this is crazy. Ooh, look at that. But it's flying off the screen, so let's not do the X anymore. Whoa, this is nuts. This is nuts. Let's make it a little faster. Whoa, that's cool. Let's do 30 over 1,000, or 1,000 over 30 frames per second. Ooh, okay. Not exactly what I was looking for, but pretty interesting. All right. Well, that's a start. Maybe I can do everything in the shader then. So we passed in something new. That's pretty exciting. That's cool. We passed in an angle and a position. Huh. And we multiplied everything by that angle. Hmm. So each point is getting multiplied by that angle. Is that what we want? I don't know. Hmm. Very weird. How do we fix this? Huh. Well, maybe if we stick in GLSL, we can find some good stuff. Rotating a geometry. Hmm. Okay. I do not have a clue. What happens if we like multiply the matrix by itself? It's probably going to break the rules of matrices. Yeah, invalid. How about that? Also invalid. Darn. Oh, it's because I got rid of the new x and the new y. All right, let's try. Does nothing. Weird. Not at all what I was expecting. And honestly, maybe I have some homework to do before I can get any further here. But yeah, I don't even know if this is worth anything to anyone, but we did make it do something. So I wonder if this is just flipped somehow. Maybe it's just flipped. Maybe we have to change the sine to the cosine for one of them, because it does look like, that's definitely not it. Let's see, what else? Oh, that's close. That's too much. Okay, let's try cosine, cosine, sine, sine. Still nothing. Oh, that almost looks like it's rotating. One half of them are doing the right thing now, I think. What if we do that? That's not the right comment. It does nothing. Darn, it's so easy to just return to nothing. Huh. Well, I need to figure out what all these different matrices are and how to use them, projection matrix and all that stuff. But that's about it. All right, I think that's all I can do for this video. But thank you for viewing. Hope you got something out of it.